Okay, now we have a beautiful product, but what's our yield? We're not going to isolate the product this time because it is certainly a mixture of a lot of things. We're going to do something different. Since it's colored, we will measure the visual spectrum, and from that spectrum we can determine the concentration of what we have from the amount of solution we have, which is 25 mils unless you added extra. You can then figure the amount of product that was there. To dilute these to get the spectrum, we really should do it accurately using pipettes and volumetric flasks. I know, even though we did a graduated cylinder first off, we probably should have done that in a 25 milliliter volumetric. But it's good practice, and we will get better results if we do the volumetric flask and the pipettes. So normally we start off with 1 milliliter volumetric pipette and dilute it to 10. Remember to use the pipette bulb. You don't have to attach the pipette bulb, just press it into the pipette. Get it above the line, drain down to the line, and transfer to the volumetric flask. You just let it drip in. This is a to deliver pipette, meaning you don't blow it out and you don't try to squeeze out the extra liquid. You just let it deliver, touching it to the side of the flask. There always will be a little bit left in the bottom. Now we'll dilute with ethanol. To the line. Then cover with parafilm, shake it up a little. And fill the cuvette. Here's the cuvette for the spectrophotometer. My cuvette here was dry to start, but if the cuvette had been previously used and contains a little liquid, you must rinse the cuvette with a current sample before filling. Fill it about 3/4 full, and we'll measure. Before you do much more, write the dilution data in your notebook. We had 25 mils after dilution at the end of the reaction. That's solution 1. Then with a pipette, we took 1 mil of solution 1 and diluted it to 10 mil in a volumetric flask. That's solution 2. Leave space after each diluted solution to enter the absorbance A from your spectrum. Here's the spectrophotometer, the SpectroVis Plus. The cuvette is in the holder right here. You see that the cuvette has clear sides and ridged sides. You want the clear sides on the white dots. The SpectroVis is attached to a computer that has Vernier Logger Pro's software on it. The first time in the day that the setup is used, it must be calibrated with a blank sample. A blank is the cuvette holding just the solvent. Here 95% ethanol. I have already done that here. Now let's look at the spectrum of the solution 2 that we made. We need to read the absorbance at the absorption maximum, lambda max. This spectrum has two maxima. For malachite green, your experiment asks you to choose the maximum closest to 616.5 nanometers. You can see that in this region, though, the spectrum does not have a clear maximum. It is a broad and jagged peak at an absorbance of about 2.3. By the way, don't forget to write this absorbance number in your lab notes. Absorbances over 2 are generally too high to be accurately measured by our equipment, and the fact that the peak is so flattened and jagged looking makes me think that the sample's real absorption is actually much higher. For our experiment, we are aiming to dilute the solution to get an absorbance between 0.5 and 1, where the relationship between absorbance and concentration, expressed as Beer's law, is most likely to be linear and more accurately measured. So our next step will be to dilute our sample again, using pipettes and volumetric flasks. Assuming you only have 1 ml pipettes and 10 ml volumetric flasks, think about what you might choose to try for the next dilution. This is always a guess, no real right or wrong answer, and then you try it and see what happens. I'll show you what I decided to try. Since our first solution was way over our desired absorbance, I'm going to try 1 milliliter of solution 2 diluted to 10 milliliters. That we'll call solution 3. Don't forget to add this data to your notebook. I'll rinse the pipette. And again. One ml from solution 2. Solution 3. Ethanol. Up to the line. Shake, and then we'll try again. Here is the spectrum from solution 3. Looks like much narrower peaks. To read the absorbance from the spectrum most easily, you can click the cursor button in the menu across the top of the computer screen, then drag the cursor to the approximate value for the desired lambda max. Down the left of the computer display, you will see the data table of wavelengths and corresponding absorbance values. Look for the highest absorbance value in the desired region and write the wavelength and absorbance in your notes. What is the wavelength and absorbance for the lambda max near 616 nanometers for this sample, solution 3? At this moment, I read the lambda max at 624.0 nanometers with absorbance at 2.015. But you will notice that the numbers fluctuate a little. So my guess is that our absorbance readings are valid at best to no more than 2 decimal places. Wait a minute, the absorbance for this hardly went down from 2.3 at all. And we diluted the original solution to 1/10 concentration. Are you surprised? Well, that's what happens when the concentrations are too high. The relationship between concentration and absorbance is not linear. That's why we are aiming for absorbance readings between 0.5 and 1. So what dilution might you do next? Like I said, we just have to try something and see what happens. I'm gonna go for another 1 to 10. Here is the spectrum for solution 4. Determine and write down the absorbance reading and wavelength for the lambda max. Well, solution 4's absorption was under 0.5. So we need a little bit more concentration, less than that in solution 3, but more than solution 4. So, since the absorbance change was getting pretty proportional to concentration change, and the absorbance for solution 4 was about 0.27 when I diluted 1 ml of solution 3 to 10, I'm going to try diluting 3 ml of solution 3 to 10 and hopefully get an absorption about 3 times the 0.27, somewhere around 0.8, which would be between the desired 0.5 and 1. So here goes. Same deal. Take solution 3 now, though, and rinse. Now, number 5. Write down the absorbance for the lambda max for solution 5. Once you get a spectrum with the lambda max absorbance between 0.5 and 1, you should take a screenshot of the spectrum for your report. We did it! Our final spectrum! Use this absorption to calculate your experimental yield.